Most artists find a way of drawing ellipses successfully, and in this still life I painted with a glass jar, the ellipses form the top of it. There's a bad edge of water in here which needs an ellipse, and the base. So there are several ellipses even in one thing. And just as a little tip, if I'm drawing, let's say, a cylinder, work out the width of it, the height of it, and then I work out the proportion of the ellipse. What you're actually looking at with an ellipse, which is in essence what we're drawing is a distorted circle, is the proportion of its height to its width. So if I'm looking at my teacup here, the height of that ellipse as it appears to its width, and obviously the angle you're at to it will make that change. So if you're right above your cup, it will be 1 to 1, a circle. But if you're at, say, 45 degrees to it, it might be 1 to 2. So the height of it is half the width. So let's work it out on that basis, and we're going to draw an ellipse in this top rectangle. So this is going to be where the ellipse is, and you can even do little diagonals and mark it off. But what I find very useful for the actual drawing of the ellipse, and I'll zoom in so you can see this, zoom, 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 there we go, is to draw the ellipse in 4 stages. So I'm going to mark off 4 points. This is for a basic ellipse. Now, I will in future lessons teach you about some sophisticated aspects of an ellipse, but probably the easiest way to draw ellipse is to start at 12 o'clock, do a nice curve down to 3 o'clock, 3 o'clock to 6 o'clock, but then I go back up to 12 o'clock and come the opposite way, back to 9 o'clock, and then down to 6 o'clock. So I do it the right half and then the left half, and that gives a nice flow to an ellipse. Okay. Technically, the front half of this ellipse should be slightly deeper than the back half of it, because this half of the ellipse is closer to you than the back half. So technically that centre point in the ellipse shouldn't quite be halfway, it should be perhaps a little bit above halfway. So if you're going to do really super detailed ellipses, that's important. But what I want to show you is something about ellipses which not a lot of people get right, and that is when you're drawing them in a different context. I'm just going to move this still life and put my sketch pad in place. So in this painting, move my camera down so you can see, I've painted a farmyard and a tractor wheel, lots of ellipses, front wheels, lots of ellipses. Okay, now I'm not going to draw that again to you, but I'm going to show you another example of ellipses as drawn at an angle. And so when you're drawing ellipses as they're upright, here's my traction engine. Now, I'm not suggesting all of you need to rush out and do a traction engine, but what I want to point out to you are how I did the ellipses. So you might just think, if you're looking at these wheels at an angle, that they're just vertical ellipses. So you've got the outer, the inner, you've got the bands and so on. There's several ellipses even of doing that. You might assume that drawing the front of the boiler here, because there's a slight angle to the front of it, it's not quite a circle, that it's again a slightly distorted ellipse, so perhaps a vertical ellipse, but you'd be wrong in both instances. Let's just secure this down with the rubber band so it doesn't get in the way. And in fact, the steering wheel of the traction engine makes a nice point. So this steering wheel is at an angle, and because you can see the shaft, the drive of the wheel, of the steering wheel, it shows you that actually you're going to draw this ellipse at an angle to this shaft, and the angle in question is 90 degrees. So basically you draw this ellipse at 90 degrees to the axis, and that's the golden rule of ellipse drawing. So in this ellipse, or actually series of ellipses, because you've got the outer, the back part of the boiler where all the rivets are, front and inner, you've got several ellipses. Because my eye level is the underneath the boiler, I'm sitting down looking up at this traction engine. The top of the boiler is at an angle, you can see that. So the axis for that boiler is at a slightly softer angle, but nonetheless at an angle. So this ellipse is actually drawn at 90 degrees to the axis on a slight tilt. Now, if you did it wrong, it probably wouldn't show so much. It would to my eye, but it may not show so much, but because it's very subtle. But let's bear that in mind. So again, these wheels are beneath our eye level, but they're also, the axis for these wheels is also, if you look at this beam down beneath here, I'm putting my pencil on it, that angle is not quite horizontal. So I'm not sure if that shows exactly in my camera, but because it's at a slight angle coming down to the left, again, these wheels are drawn at 90 degrees to the axis. So what I'm going to do is just draw you an example of this. Let's move this over. And let's imagine we're looking at, up at a tall tower. Let's imagine we're looking up at Big Ben. And in fact, I've got Big Ben right handy here. Hang on a sec. So here is Big Ben. Now, I'm looking at this tin of Big Ben at eye level, but if I put Big Ben up high, going off your camera there, so I'm going to zoom out again so you can see. If I put Big Ben up high, let's go up here, just like I'm looking at it from street level, it becomes distorted. I'm going to draw it and show you what I mean. So Big Ben up high is actually, we'd be looking at the tower of Big Ben. We draw the nearest side of it first, so let's just draw a straight line. Let's draw the left side of it and the right side of it. Now when we look up at the tall tower, as explained in my painting of a church video, we've got 3-point perspective. You get vertical distortion, and when we get vertical distortion, it's just because the top of the tower is a long way up in the air. It's further away from us than the base of the tower, so even if the closer we get to the tower, the more distortion we get. So the top of this tower is, I'm guessing, say half the width of the bottom of it, the base of it, because it's twice as far away. So very simple equation. So let's draw the top of it, and I'm going to draw the angles of the top of it. So we're looking up at a steep building, and I'll zoom into this so you can see it again. So we're looking up at a steep building. Now let's suppose it's Big Ben, and we've got to draw a clock up in here. So we've got the clock over here, you can see. I'm going to draw the rectangle. I'm not going to draw the top bit of the tower for this exercise. I'm going to draw the rectangle that's distorted. This is the rectangle in which the clock sits. So it's at an angle. There's another clock on this side at an angle. In fact, we'll just reduce the rectangle down because it's not the whole width. But my point being is we've now got to draw the clock. So it's not just like drawing this cylinder as I did lower down here. Let's complete that, by the way. Let's draw the base of it. Draw the base, draw an ellipse as if you're going to draw a complete ellipse, even though you can only see half of it, and then rub out the back of it, and then you'll end up with a nice cylinder, like so. So that's that. In this instance, the clock face, we'd have to imagine where the axis of that clock is, the spindle that the hands are on, and it would go back into the building like this. So the clock face would be at 90 degrees to that angle. So it would be, so I would actually draw this ellipse on a line like this. I've got to work out how fat it is, so how distorted it is, what's the ratio, and then I can draw my clock. So let's just draw the clock, and that clock face now will be in the correct perspective. So let me just hold that up to show you closer and closer. So that's in the correct perspective. I'm going to draw the clock on this side in the wrong perspective. So if I just draw a vertical ellipse, it sort of looks right. I'm going to now zoom in a bit more so you can see. Let's go up into here. But it's not right, and in fact that is distorted in the wrong direction. So if I now draw the axis, this ellipse is a bit softer like that. I draw 90 degrees there, and now I'm going to draw this correctly. It's not a huge difference, but it's a significant difference. So I'm going to draw an ellipse going like this, and so it goes up there, it cuts in there, it goes down there, and it just makes it fuller in parts of it and thinner in other parts of it. So now that clock face that I've probably got the ratio on is drawn. It's probably not as wide as that one, so I need to make it a bit wider. But that clock face is drawn at this angle, it makes it correct. So it might seem very technical, but as you can see from the traction engine, which I'll bring back again, and as you can see from the wheels of that, the wheels of the tractor I did earlier, you must always draw your ellipses at 90 degrees to the axis. There you go, so there's our traction engine, 90 degrees to the axis. Okay, so axis, draw perpendicular to that, 90 degrees, and then draw the ellipse on that. And then hopefully your wheels on your wagon will go round happily. Thanks for watching.